In this video, I'll show you how to tune and test random decision forest models with Skytree. To invoke the random forest model of Skytree, you simply have to use the RDF option with the Skytree server command. And to set various options for the RDF model, you need to specify the option name and followed by the value that you want to use for that option. Typing --help after Skytree server RDF will give you all the available options for the random forest module with quick descriptions for each one of the options. This is a great way to look up the syntax for the available options and also to quickly look up what each option does. And for more detailed information, please refer to the user guide, which has all sorts of descriptions and examples for all the possible options. Here's a simple random forest run that trains a random forest and saves the resulting model. We begin by specifying the RDF option, which invokes the random forest model, and we then specify the file that has the input columns of the training set. And we do this by using the training in option. After that, we specify the file that has the correct labels for the training set. And for this, we use the training labels in option. And we then specify the number of trees we would like to have in our random forest. This is actually the only required parameter for a random forest in Skytree. All the other parameters have default values. But for the number of trees, you actually have to pick a value. For this particular run, we will use 100 trees. We would like to write out the random forest model to a file so that we can use it later on other datasets to make predictions. And for this, we use the model out option. This writes out the model into a binary file that Skytree can later read and use. And we're also using the Linux t command to write out the log that's printed to the screen simultaneously into a separate file. So let's give this run. And let's now open the log file that we wrote out. We see that Skytree begins by printing out some basic system information, like the type and the number of processors, memory information, username. And after that, we see the current working directory printed out and also the exact command line arguments that we specified. So after this, the run starts. And Skytree prints out system status information and the options that we specified. And that's followed by a progress report that's shown during the run. And finally, Skytree concludes by printing out the total time taken and the peak memory used. In this run, we also wrote out the model, but we won't inspect that file since that file is a binary file. We created a random forest model and saved it into a binary file, so we can now use that model on a test dataset to obtain predictions. To do this, we begin by specifying the RDF option again, and we then specify the file where we have the model, and we do this by using the model in option. After this, we specify the file name for the data, and we do this by using the testing in option. Finally, we choose a file name to write out the predicted labels using the labels out option. So with this run, Skytree will read the model in the file rdf.simple.model and read the data in the file income.test.st and write out predicted labels for this test data into the file rdf.simple.labels. So let's give this run to make predictions using the model that we wrote out. We see that the log that's printed to the screen is pretty similar to what we saw in the previous run. And now that we wrote out the predictions, predicted labels, we can take a look at them. So these are the plus or minus 1 labels that were predicted by Skytree using the model that we wrote out. In our previous run, we predicted the classes for the test data. But often we don't just want predictions for the classes, but we also would like to know how strong those predictions are. And for that purpose, we can use the Probabilities out option of Skytree and simply specify a file name where we want to write out the probabilities. So this will write out the probability value for each test point into the file that we specify. So this run is almost exactly the same as the previous run. We specify the RDF option, the model file, and the file for the testing set. And in addition to the file for the predicted labels, we also specify a file for the probabilities now. Note that we don't need to train a new model here. The one we saved is already capable of predicting the probabilities in addition to the labels. So let's give this run to write out the probabilities together with the labels. And let's take a look at the probabilities and the labels. We're going to use the Linux paste command to show these files together side by side. So the first column we see here are the probabilities predicted by Skytree, and the second column we see are the labels predicted by Skytree. So by default, Skytree labels any point that has greater than 50% probability of being class 1 as class 1. And that means Skytree uses a 0.5 probability threshold for labeling a point as class 1. So if we look at the first few lines of this file, we see that the first couple of lines have probabilities less than 0.5, so they're labeled as -1. And the next couple of lines have probabilities greater than 0.5, and they're labeled as +1. We just saw that by default, points get labeled according to a probability threshold of 0.5, but this is not always the best choice, and you may want to use a different value for the threshold, and this can be done by using the probability threshold option, and the command you see is a simple example of that. Once again, we're specifying the RDF option and the files for the model and the test set, but this time we're also using the probability threshold option to specify a threshold of 0.8. And we're also specifying a file to write out the predicted labels using this threshold. So let's now give this run to write out the labels predictions, but this time we're going to use a threshold of 0.8. And let's open the labels that were predicted using this threshold, and we're going to print them out together side by side with the probabilities that we wrote out in the previous run, and we're going to use the Linux paste command to do this. So the first column here is the probabilities that were predicted, and the second column is the labels that are predicted. So looking at the labels and comparing them with the probabilities, we see that a threshold of 0.8 has been used. So even though certain points have probabilities greater than 0.5, they have been labeled as -1 because we use a threshold of 0.8. So up to this point, we just randomly picked some number of trees and built models using that number, and we did not touch any of the other options for building random forests. But as with any other machine learning method, one actually needs to tune all the parameters of random forests to obtain models with high accuracy. With random forests, one typically tunes over the number of trees and the number of dimensions, but there are also some other additional parameters that one could tune as well. So in order to do tuning, one needs to pick a validation scheme, like using a holdout set or doing cross-validation. And we will next give a simple example of tuning that uses a holdout set. We will tell Skytree to put aside a randomly selected 30% of the data and not use it when building the trees of the random forest. Only after the forest is built, Skytree will use the 30% holdout set to evaluate the performance of the forest. Going over this procedure for various parameter settings, Skytree will pick the best setting. Here's a tuning run for a random forest. We begin by specifying the RDF option as before, and the file names for the training input data and the labels using the training in and training labels in options. We then specify the holdout ratio option with the value of 0.3. This will actually make Skytree put aside a random 30% of the dataset for evaluating the models. So by simply specifying the holdout ratio option, we turned on parameter tuning. We then specify two parameters to tune over. We would like to tune over the number of trees by trying out the values 10, 20, 30, 40, and all the way up to 100 trees. And this column notation here is just a shorthand for that. This works by first giving the starting value of a parameter, in this case 10 trees, and then the step size, which is 10 trees also, and then the ending value, which is 100 trees. So this will make Skytree start at 10 trees and go up to 100 trees with steps of 10. If you have specific values you would like to try instead of a uniform list like this, then you can list the values that you want separated by commas. The next parameter we would like to tune over is the number of dimensions. Random forests build trees by considering only a subset of all the possible dimensions at each split. And the num dimensions option of Skytree specifies the number of candidate dimensions to use at each split. For this run, we're once again using the column notation to choose 3, 5, and 7 dimensions. To pick the best model among all the ones that we try, we have to actually specify a criterion. And for this, we use the testing objective option, and then specify the criterion that we would like to use. So in this particular run, we would like to maximize the classification accuracy, which is the same thing as the fraction of the correct predictions, correct label predictions. If you would like to use other criteria, such as the F-score or the Gini score, you can pick those too. We then use the tuning results out option to specify the file where we want to write out the tuning results. So this file will contain the tuning results in a nice tabular format that we can read later. We're also writing out the final best model found as a binary file. We could have left it at this and perhaps read that model later to test it on a separate test set, but we can also do the testing in the same run, and that's what we do here. We specify the file that has the test set using the testing in option, and specify the files to write the predicted labels and the predicted probabilities using the labels out and probabilities out options. So let's give this tuning run. And let's open the tuning results file that we wrote out in this run. So this file contains the tuning results in a comma-separated value format. The first line has the names of the columns, and we see that the first 5 columns or so have the parameters that we tuned over, like the number of trees, the number of dimensions, and the tree depth. And the parameters that we did not specify appear as fixed. And the next 5 columns are the various measures of performance, such as the Gini score, the capture deviation, the precision, and F-score. And the final few columns have the probability threshold values for various measures of performance. So a given random forest can predict probabilities for the 2 classes, and to predict the labels, we have to choose a threshold for the probability, and different threshold values will be needed to maximize different measures of performance. And these final columns contain the appropriate threshold values for the different measures. Many real-world datasets have a significant degree of imbalance. For example, if we're trying to build a system for detecting fraud in credit card transactions, our training set will contain many more non-fraudulent cases than fraudulent cases. And with such a high degree of imbalance between the 2 classes, straightforward applications of machine learning methods may not result in good accuracy. There are various methods for dealing with imbalanced datasets in Skytree, and we will start with the simplest one, namely using the -- imbalance option. And this can actually be quite effective. Here's a simple run with the imbalance option. This is quite similar to the runs we gave before, so let's quickly go over the options we're using. As before, we start with the RDF option name and specify the files for the training inputs and the training labels. We won't be tuning parameters in this one, so we just pick a specific number for the number of trees. We pick 100 trees. We then specify the imbalance option. And note that we do not specify a value for this option. Simply writing -- imbalance tells Skytree that we would like to treat the dataset as an imbalanced dataset and do the necessary adjustments. We then specify the testing file that we want to read, and the output files for the model that we want to write out, and the predicted probabilities and labels. With this run, Skytree will create a model using the training set, and doing the necessary adjustments for the imbalance in the data. And then it will use that model to make predictions on the test set and write out those predictions, and also write out the model that was obtained. So how does Skytree take the imbalance into account? With the simplest approach we're using in this run, Skytree randomly downsamples the more frequent class so that it has the same number of points as in the minority class, and trains a random forest model on the resulting dataset. Of course, in RDF, random decision forest trained on this downsampled version of the dataset makes distorted predictions for the probabilities for the two classes. So Skytree applies a correction to the estimated probabilities and uses those corrected values to predict the final labels. So let's give this run to take into account the possible imbalance between the two classes. And let's just take a quick look at the probabilities that were predicted. And these probabilities are going to be different from the probabilities that were predicted by giving a run without the imbalance option. So the imbalance option modifies the probabilities that are predicted. So by default, the imbalance option downsamples the majority class to make the two classes of equal size, and then it performs the training. But Skytree also provides the user with more detailed control over the treatment of imbalance. It does this by using the imbalance scale option or the sampling ratio option. The sampling ratio option allows the user to specify specific sampling ratios for the two classes. For example, if you want to downsample the majority class by a factor of 100, say, and upsample the minority class, so by upsampling, of course, we mean sampling with replacement. Say we want to do that by a factor of 2, you would specify the appropriate sampling ratios for the two classes using this option. The imbalance scale option is actually a simplified version of the sampling ratio option. This simply samples the two classes to make them of equal size. For example, if you choose imbalance scale 2, the majority class will be downsampled and the minority class will be upsampled, so that both classes have the same number of data points, and that number of data points will be twice the number of points in the original minority class. So specifying imbalance scale 2 will make both classes have the number of points equal to twice the original number of data points in the minority class. With imbalanced datasets, you can first perhaps try the simple imbalance option and see if that gives enough improvement in accuracy. And if you would like finer tuning, perhaps you can go over the imbalance scale option. And for even more detailed tuning, you can try the sampling ratio options. So let's next look at an example for tuning over the imbalance scale. We begin by specifying the RDF option and the file name for the training data and the training labels as usual. And we use a fixed number of trees. And to do the evaluation for the tuning, we will use a 30% holdout set. And we then specify the imbalance option. And in addition to this time we also specify a range of values for the imbalance scale. So we are using values starting at 0.5 and going up to 2 with steps of 0.5. So for each value of this parameter, Skytree will sample the two classes accordingly. For example, for imbalance scale 1.5, the majority class will be downsampled and the minority class will be upsampled with replacement, so that they both have the same number of points, which is going to be 1.5 times the number of points in the original minority class. We will write out the tuning results to a file, and we will also use the Linux T command to both see the output from Skytree on the terminal and also have it written to a file. So for this particular run, we're not writing out the final model, and we're not making any predictions on a test set run. So let's give this run to tune over the imbalance scale. And let's take a quick look at the tuning results file. So we did not tune over many of the parameters, so things like the number of dimensions and the tree depth are all fixed. We do see that the number of trees varies between these different rows, and that's because that parameter tuning actually comes for free. Skytree does not have to give different runs for different numbers of trees. And it just records the accuracies for these different numbers of trees anyway. And the thing that we did specify in this run was the imbalance scale. And as we have already seen, the imbalance scale actually translates to different sampling ratios for the two classes. For example, for imbalance scale equals 0.5, the minority class is downsampled to half of its size. And the majority class is downsampled to have the size equal to this minority class, sampled version of the minority class. And for imbalance scale equals 1, the minority class has the same size as the original minority class, but the majority class is downsampled to have the size equal to the original minority class. And the imbalance scales of 1.5 and 2 are also tried with the corresponding sampling ratios. And with the other columns, we see the accuracy values for these different tries, and we also see the appropriate probability threshold values for the different measures of accuracy. With tree-based models, there are ways to assess how important each variable is for predicting the output. And one way to quantify this is to look at the splits that use a particular variable in all the trees of the model and calculate how much those splits reduce the so-called impurity of the nodes. And a sum of all these impurity reductions gives a measure of the importance of that particular variable. So to use this notion of variable importance and obtain the importances for each one of the variables, with Skytree we simply use the variable importances out option and specify a file name. And the file written out will contain one line for each variable, and each line will contain the importance of the corresponding variable. The values are normalized so that the most important variable always gets a value of 100, importance value, and the ordering of the variables in the file is the same as their ordering in the Skytree data file that was used with the modeling run. Here's a run that first tunes a model, trying 4 different values for the number of trees and a 30% holdout set, and then writes out the best model found and also the variable importances for that best model. So let's give this run to write out the variable importances. And let's skip the tuning results file and the log file in this case, and let's just look at the variable importances that we wrote out. So this file has one row for each column of the data file that we used, and each number corresponds to the importance of the corresponding column in the original data file. So these are normalized so that the number 100 represents the most important variable, and all the other ones are scaled accordingly. In this video, we saw how to train and tune random forest models with Skytree, and we did this by using a holdout set, but it's also possible to do the same thing using a cross-validation or using a separate tuning set specified by the user. We saw how to handle imbalanced datasets using the imbalance option or imbalance scale option or the sampling ratio option, and we learned how to tune these parameters for imbalanced datasets. And finally, we saw how to obtain the importance of each variable in making the prediction. This gives you the capability to use the core functionality of the RDF module of Skytree and build accurate models. You're welcome to explore the user guide or the help option for the RDF module of Skytree to obtain detailed information about all the other possible options.